And then we have a startup from US, Ascribe, who's going to be talking about their experience on how they have built up an ecosystem to address the farmers. And finally, we have our speaker from Netherlands. Now I'll introduce all of them, and I would like all of them to come to the dais. First of all, our moderator is Mr. Mark Kahan, Managing Director, Partner, Omnivore. Please, sir, come to the panel members. I invite them, Mr. Raj Ganguly, Senior Agribusiness Specialist at World Bank, New Delhi. We have Mr. Suman, Director, Climate Action, Rural Livelihoods, Dr. Reddy's Foundation, India. We have Mr. Ravi Teneti, CEO of the BEST, Foundation for Bengaluru Science and Technology, Indian Institute of Science, India. Dr. Murli Manohar, founder, Ascribe Biosciences, USA. And Dr. Neha Avasti, project leader and domain expert, Biosciences, One Planet Research Center, Netherlands. And after our discussion, a short presentation by everybody of you, we will also have a surprise guest from South Africa. I'll bring in her later, who will be then telling her about her experiences in this domain. Thank you all, and I would like to now ask Mr. Mark to take over.
Is the presentation loaded? Where is it? Yes. We're just going to wait a second and get this presentation loaded. It's an honor and a pleasure to be here at Global Bio India 2024. My name is Mark Khan. I am a managing partner at Omnivore. Omnivore is a leading venture capital fund in India focused at the intersection of agri-food, climate, and the rural economy. We've been around for about 14 years. We're backed by marquee investors. And we were one of the first Indian venture capital funds to begin investing in the life sciences space very actively with a focus on agriculture and climate. Do I have a presentation? I'm happy to ad-lib, but it would be nice to, there we go. So, today we're going to be talking about enhancing food security through life science innovation. I hope the clicker works. So I think it's probably obvious to everyone here that India needs to boost crop yields and feed its growing population, even as agricultural production itself depletes water tables and soil health, right? This is like the fundamental challenging equation of Indian agriculture. You know, what we are dependent on also depletes. And so we are faced with a variety of trends that are not getting any easier, right? From a climate change perspective, we have changing temperature patterns. I think anyone who grew up in Delhi remembers when Septembers weren't this wet, right? We've seen the monsoon, even in the 16 years that I've been based in India, we've seen the monsoon change radically. And of course, it's even more different from decades past. You have changing precipitation patterns in addition to the changing temperature patterns. And you have sea level rise. So you have these fundamental changes from the climate. And then from just existing agricultural production, you have degradation of soils, you have declining water tables, you have a vicious cycle of increased fertilizer and pesticide usage, and you have the homogenization of landscapes and ecosystems. You have, you know, the fundamentals of the Green Revolution created food security in India, but now many decades later, the continuation of those policies threaten our environment and threaten our food system. And so what saved us now threatens us. And when you look at the impact on Indian agriculture and food systems, four major trends. You have falling yields for staple crops, or we're facing a future of falling yields for staple crops, where changing climate patterns will decrease the probability will increase the probability of yield declines. You have heat indexes reaching a point where it's actually dangerous for farmers and farm laborers. You have changing cropping patterns in response to these temperature and precipitation impacts, which will change where and how we have to farm. And there's an enormous livelihood challenge that is borne by some of the most precarious parts of our population. So suffice it to say, all of us here that work at this intersection of agriculture and technology will be very busy in the coming decade. Innovations in agri-food life sciences can play a critical role in tackling climate mitigation, adaptation, and resilience. So when we say agri-food life sciences, we're mostly talking about four big areas. One is agricultural biotechnology. Let's be clear, I don't just mean GMO. Okay, GMO has effectively, since 2009, been on life support in India. Might change in the future, but seems unlikely. But there is so much more than just old school genetic modification. Like, we're not in the late 90s anymore, even if the kids are recycling the fashions from that time. So when we talk about agricultural biotechnology, we're talking about on-farm inputs for crop and animal agriculture, and that includes hybrid seeds, that includes breeding and genetics, but that also includes microbials, animal health, that includes CRISPR, that includes RNAi, right? And we're looking at these technologies to improve soil health by reducing the use of toxic chemicals and enabling farmers to deal with abiotic stress. We're also very interested in novel farming systems. Some of this is controlled environment agriculture, RAS, recirculating aquaculture, insect protein, algae production, and every manner, right, of new farming systems that break away from this dependence on climate and this dependence on soil. We're also very interested in bioenergy and biomaterials. So how do you take agricultural wastes, process them, produce biomaterials, transform feedstocks, and replace unsustainable incumbent materials like plastics in industrial value chains. And finally, innovative foods. This is a weird moment for innovative foods because we've been through this whole cycle, not so much in India, but globally, where everyone was super excited about alternative protein and now no one wants to touch it. But fundamentally, there have been breakthroughs in plant-based fermented and cellular proteins, as well as other functional foods and novel ingredients. And all of these can reduce GHG emissions within our food system. One critical point is that private capital needs to step in and step up and close the funding gap in agri-food life sciences. It's very interesting. People always complain about government, but the truth is the government has been carrying the load in this sector when the private sector could barely care in the space of bioinnovation. And it's only more recently that the private sector has been catalyzed to take action. India is emerging as a hub of entrepreneurial innovation and success in biotech. But private investors are still fundamentally on the sidelines. You have some brave pioneers like Omnivore, and we have other peers, but growth capital in the space is negligible. And if you want to raise a growth round in life sciences, you basically have to fly to Boston or San Diego. And despite the establishment of premier educational institutes and laboratories to train talent, one of the challenges in India is that we lose some of our best talent, much of our best talent in the life sciences abroad. That used to be true in everything. That was true in engineering, that was true in management, that was true in software, that was true in finance. None of that is true anymore. From the IITs and the IIMs, the best talent no longer goes abroad, it stays home. But students who are studying biotechnology, biochemistry, they still mostly go abroad for their PhDs and stay. And that loss of talent impacts the state of our ecosystem. And it's critical to bring that talent back to India as part of the way we think about building this ecosystem. As I mentioned, the government has taken laudable steps towards funding, that critical grant funding and pre-seed funding. We owe so much to BIRAC, so much to CCAMP, right? The Bangalore Bioinnovation Center, the IKP Venture Center in Pune, and many others whom I'm sure I will be reminded that I forgot. But it's reached a stage where funding is needed for that seed round, that 2 million, that 10 crore, 20 crore, $2 to $3 million seed round. And we need to catalyze private capital in this space at every stage. And existing organizations and associations like FICCI and CII and ABLE are trying to bridge the funding gap, but they're limited to the very, very earliest stages of incubators, academia. So basically what I'm saying is that we have to pull ourselves up by the bootstraps. And those of us that are venture capitalists, that are early stage investors, need to start spending time in the sector, learning it, understanding how it's different, and deploying capital. Because you cannot solve the challenges of Indian climate with digital technologies alone. It requires life sciences to achieve the breakthroughs that we need for our future. So, in today's panel, we're going to talk about how agri-tech innovations, including in life sciences, can unlock food security in India. And I'm just going to give the panelists a little warm-up about the questions that will follow. We're going to talk about the challenges with the adoption of available technologies in India's farming ecosystem. We're going to talk about the critical investments and partnerships that should be explored for driving food security. We're going to talk about the key policy interventions required to build a sturdy agri-food system. We're going to talk about how private sector investors can support the life sciences ecosystem and what needs to change for that money to be unlocked. We're going to talk about lessons from other countries, because we can't just look internally for our solutions. And we're going to talk about how to foster collaboration between research institutions, startups, and established agribusinesses to accelerate innovation. And finally, what strategies can be employed to attract and retain young talent in the biotech sector, and even get talent that has gone abroad to come back home. We have a fantastic panel for you today. So I've already introduced myself. I'm a strange American who's been in India for almost 2 decades. My background is in the agribusiness sector. I used to work for Syngenta, one of those big global ag companies everyone is very scared of. I actually moved to India working for a large Indian corporate, Godrej Agrovet, where I was for 6 years, and then founded Omnivore in that context as the first agri-tech VC in India. We also have Raj Ganguly, who is a sector agribusiness specialist from the World Bank. Mr. Ganguly, please, hi. We have Suman, the Director for Climate Action and Livelihoods from the Dr. Reddy's Foundation. We have Ravi Tanetti, CEO of the BEST, the Foundation for Bengaluru Science, and coming from the Indian Institute of Sciences. We have Dr. Neha Avasti, the project, Neha, okay, so we jumped a bunch of seats. The project leader and domain expert for Biosensors Institute for Molecules and Materials and One Planet Research Center in the Netherlands. That is quite a mouthful, ma'am. The longest name of an institution I've ever seen. And no, but we have others, and unfortunately for some reason they're not in this deck. 1 second. Okay, so clearly we lost a couple of slides. That's kind of fun. So what I would suggest is I'm done with my presentation. We have this gentleman here from Inera Absolute. We have a gentleman here from Ascribe Biosciences in the US. So everyone's going to go make their presentation. Please introduce yourself properly, because I've had to buzz through this, in some cases with no context. And after those presentations are made, we're going to regroup and then begin questions to the panel. So I guess initially, Raj, you're going to start, right? Very good. So I'm calling up Raj Ganguly, the Senior Agribusiness Specialist from the World Bank. Thank you. Please.
Can I have the presentation loaded, please? Thank you. Thank you, Mark. Thank you for the wonderful introduction. And you have set the context very well. And I think you have made our job a little easier today. But let me see how I can contribute to this conversation. And I look forward to hear from the other panelists, and also, with your permission, if we can also invite some questions from the audience, that will be fantastic to have more depth in the conversation. I am Raj Ganguly. I'm working as Senior Agribusiness Specialist with World Bank in New Delhi office. And this is my second interaction with biotechnology sector. And what a energy that is there in this hall and in the entire event. So first, congratulations to BIRAC for taking this forward, our biosciences and research to bioeconomy, which India is very well poised to make its own dent and creates its own leadership in the global arena. I must also thank Ms. Amisha for inviting me here, and thank you for all the coordination. I wanted to celebrate through my first slide about the BT cotton success story in India, how it has successfully reduced chemical utilization and how it has also contributed to farmers' health impact and overall health impact. After this, there has been many such endeavors through which biotechnology sector is bringing revolution in food space. Second slide, please. You have, Mark, you have touched base on the need for this, revolution, and I just wanted to highlight the nutrition aspect in the food. We all know that, yes, we know for increasing population, how the food requirement is going to be high. We all know that around 750 odd million people still are undernourished. We also know around 2.3 billion people in the world, they are facing hunger and hunger in this world. This is FAO reports. But what we are also concerned that on one hand, we have food requirements that will double by 70% by 2050, and we need to all gear up towards that. But the way we eat food and the way it is getting assimilated into body and the way it is creating health impacts is also throwing new challenges. Like the obesity is increasing, we have undernutrition and malnutrition situation that needs to be tackled, and it is not limited to only the bottom of the pyramid, but also in the cities there is a increasing nutritional challenges. So how, through a food system approach, we look for newer technology solutions to address these challenges needs to be thought through.
सर इससे फॉरवर्ड है इससे फॉरवर्ड
Sorry for my this uh, technology illiteracy. Yeah. So now it was quite fantastic to interact, few entrepreneurs in this pavilion also, and I'm impressed the way the young generations they are applying the frontier technologies available in biotechnology. Today we have, total genome understanding of human beings also and the various crops and plants, and also we have frontier cutting edge biotechnology solutions with which we can manipulate not only the genotype but also through the digital technologies how we can control the environment side. We all know that this G plus E interaction helps us to get the right kind of phenotypic expression with which we know we can find our solutions. So in that endeavor, how do we see the marriage of these two technology domains together, biotech and digitech together with a blended approach? Not only it helps to advance the researches, but also it helps to delivery of the researches for the scaling requirements. Uh, Friends, we need to see this hunger and nutrition challenges which we are talking about in the context of the premise that we are in. While for the smallholders and the rural areas, we have malnutrition challenges, undernutrition challenges, and increasingly obesity challenges also there. But tackling those challenges require a different set of perspective and premise than what the opportunities or the challenges that is coming up from the top of the pyramid, from the urbanized cities. We know that globally now around 56% of the population is in the cities, and increasingly that will increase further. We'll have newer, opportunities to serve the urban dwellers. How do we do that? And how do we do in a way that the food that gets delivered is safe, the food that gets delivered is carbon neutral, and we have the nutritional requirements like the urban customers is looking for, that is delivered in a meaningful way. I would also like to throw to the panelists and to the audience that while we are thinking to enhance production, we must also see that how do we manage our food. Globally, around 1/3 of the food produced is wasted, and that's a concern not only for the environment, but also it's a concern that a lot of energy gets wasted there, and we are not getting the full efficiency of it. I was talking to one of my co-panelists, and he was telling that we need to discuss this waste part. Mark, you also covered this waste, but to me, it's a wealth. All the biosynthesis that is happening, we need to see that what more value creation can happen and how that could translate into our natural fibers, natural feed for the our livestock, our pharmaceutical produce that can come from many byproducts. So we need to examine and we need to see those value propositions there. I will share some of the cases through which we can see that how it could be advanced. And I'm sure we are going to hear more from the panel on these aspects. This is a photograph from one of my farmer in Northeast Nagaland, if you have ever been to. And I would like to draw upon some of the fundamentals. Mark already talked about soil and water, but I would like to emphasize here the importance of biodiversity also. So soil, water, biodiversity, these natural capitals, these are the treasure house for us to see that how we advance the bioeconomy. And particularly, Mark, besides the soil and water, we need to see that how we understand the biodiversity. This lady is growing a plant. I'm not sure if you all know about it, but there is a HS code to this plant, and it is a internationally traded commodity, and it's an excellent gelatin. It's a natural color. These leaves are cherished by our Andhrites as gongura chutney, and this is a fiber plant. So under climate change situation, how do we understand these versatile plants? This is Hibiscus subdyrifa, and you will find in our backyards many of such plants. But when I was studying, I was told about it as a fiber crop. We didn't examine the nutrition side of it. We didn't see the value of the food and the other secondary and tertiary attributes that such plants bring. And we have plethora of such plants and insects and livestock that is there up in our backyard, in our forest. How we help tap that. And together with that, I would also like to emphasize that how do we understand the human capital? Because the producers, these small farmers, the collectors of these plants from the forest, they bring the indigenous knowledge, which will be very crucial when we think of advancing the bioeconomy. We at World Bank, we are thinking that how we can shape up the security of food and nutrition in the world to not only see that we have enhanced quality of life, but also how do we secure the planet health. So at World Bank, we are seeing that how food and nutrition security challenges could be addressed through the frontier technologies by leaving behind a livable planet and also enhancing quality of life, as this forum also is thinking about transforming lives. Now, coming back to agro startups, which, when they work with many new ideas and they would like to commercialize it, when they research and when they invest in the research, and we have persons like Mark, with their organization, they take the risk of investing in such organizations. At times, these organizations get entangled into a very complex cobweb. And besides, focusing on the technology or innovation side, they get entangled in, how to raise resources, how to raise, how to manage the human capital, how to see that they compete in the world, how do they network with the other organizations working in that sector or subsector. So unless that facilitation is there, they find themselves quite entangled into the cobweb to and then that limits the growth story of such wonderful startups. We need a structured ecosystem for advancing the such innovations. Uh, how do we ensure some public sector investment in upstream investment in research and analytics? How do we support and handhold these agro startups midstream, maybe through some risk fund arrangements and all? And how do we see that downstream we support them to connect to the market requirements? I'll be a little faster here, but I would like to here spend Mark two success cases where way back in 2006, World Bank invested with Indian Council of Agriculture Research to advance the agriculture technologies and innovations. And this project, which ended in 2014, had excellent infrastructure was laid out for incubators and for the startups, and it supported successful commercialization of many technologies. It also created networking with world scientists and researchers. Similarly, the biopharma mission, which BIRAC is championing, that is funded by World Bank, and there also a very nice, train to rail concept of innovation advancing, is happening. This project is already, very successful so far. It has 53 product prototypes developed, some 18 technologies have been licensed, and some 200 companies that has been supported are using shared facility. So we need such ecosystems to grow and see that how India can leverage such ecosystems to launch itself into the global bioeconomy market. Besides World Bank, we have within World Bank we have International Finance Corporation, which is also supporting such venture capital, and through venture capital the disruptive technologies. We have also investment in Omnivore and various other organizations, and we are very proud that how through such catalytic investments the innovations are getting advanced. To take it forward, I am leaving behind this food for thought for everyone to consider, that if we need to advance the national bioeconomy and bring it to global stage, noting its rich natural capital and the human capital it enjoys with a young population, we can think about an agriculture-led biotech green revolution that could be using the digital technology and biotechnology in a blended approach to see how this deep green food system revolution can bring in inclusivity, sustainability, resilience, and net zero food system, not only for India's but also for global market. I will be encouraging all of us to see that now how the worldwide various countries are advancing it. I'm leaving behind a case of Euglena from Japan, how they have concentrated a small microalgae and they have various different diversified applications from not only from food and nutrition, but also to bioenergy. This company puts sustainability first as their core value proposition, and they have spotted that in Bangladesh the malnutrition issues could be solved by this algae, and they are supporting Bangladesh by bringing in Euglena fortified cookies. And such a kind of an approach we need to see. How do we understand the natural economy, a natural capital, and then understand these microbes and add value proposition through it to bring in changes to the lives of people and to the planet health. So with this, I leave behind these thoughts with you. I'll be happy to take up a few questions as time permit. Thank you so much.
So that was Raj, senior agribusiness specialist at the World Bank. Just got the notes that I needed to do the intros properly. So just as background, since he didn't have a chance to give it, Raj has extensive experience in South Asia, focusing on rural development and food systems issues like market creation, value chains, and entrepreneurship through technology and innovations. He holds a degree in agriculture and postgraduate qualification in horticulture and agribusiness management, and worked for various national and international development organizations before joining the World Bank. Next, going to be calling Mr. Suman. So as background, Suman is the Director of Climate Action and Rural Livelihoods at Dr. Reddy's Foundation. At Dr. Reddy's Foundation, Suman's team focuses on climate action and rural livelihoods, creating a positive impact in underserved communities. Driving the operations, they have designed and implemented regenerative agriculture, rural entrepreneurship, coastal ecosystem-focused community engagement, and sustainable skill development models, and forged vital partnerships, enhancing both environmental stewardship and socioeconomic growth. Suman has a role in leadership, building on a strong foundation in project management, training, and social entrepreneurship. Collaboration with government bodies, corporate partners, research organizations, startups, and NGOs has been an integral part of his work. So please welcome Mr. Suman from Dr. Reddy's Foundation, who will be speaking to you next.
So first of all, thank you, Mark, and thank you very much for all the co-panelists. I look forward to learn from you about the great work you are all doing it. And thanks for the audience who have been, after the lunch, it's always difficult to attend and pay attention. We will try to make our all best possible efforts to get your attention. Okay. Now, coming to my contribution to this panel discussion is about how we have tried to integrate soil biologics interventions as part of our soil health improvement and improving the productivity of farmers. So how exactly this entire soil biologics come into an interest as well as the pertinent to us? So one is that soil health, nutrition, nutrient cycling, water retention, carbon sequestration, and pest management. This is where we see that there's a common, or we have to focus as part of our regenerative agriculture program. And second thing, as my co-panelists already mentioned, biodiversity, enhancing the microbial diversity through biological products contributes to overall ecosystem health. So that is where this entire biological products also play a very, very important role for us in promoting regenerative agriculture. Now, apart from soil health and biodiversity, this entire system of ecosystem services, be it nutrient availability, improving the soil structure, as well as enhance the crop resilience, because climate action is already in action. So, and soils are degraded, food security is at risk. So hence, we have to really look at it as an ecosystem service in terms of how soil biologics can play its role. Now, what are the use cases in terms of our geographies. We see biofertilizers making soil more alive and reducing the impact of synthetic fertilizers, over usage of synthetic fertilizers, I must say. So nitrogen fixing bacteria, phosphate solubilizing bacteria, and this entire beneficial fungi. So these are the three areas in which we are trying to integrate these products as part of the RA system, so that the dependency of farmers on synthetic fertilizers comes down, and in a long run soil health can be improved. The other area is about biopesticides and plant metabolites, where we are promoting beneficial bacteria and fungi and nematode related activity, as well as the entire flavonoids and auto-induced peptides. So these are the two large areas where we have been focused, and we have been trying to introduce relevant solutions by startups as well as the companies to the farmers, so that the awareness gap is addressed. At the same time, use case is also addressed across multiple states of India. Now, how exactly this works in terms of soil amendments is also compost, vermicompost, and biochar. Biochar has been, people who are into climate action and into bio waste as well as everything, they would have been hearing again and again about this biochar. How exactly biochar as a soil amendment coming from the bio waste has to be mainstreamed. These are all things which we have been focused, and these are all the use cases which I see from this particular conference, which we have to take collectively. Now, coming to the usage of this entire biological products, what we realized is that it is definitely adding value in terms of increased yields of rice, wheat, and maize, which are typically 60% of the anytime the crop area would be under these three crops, where we see that there is a definite increase in terms of yields by application of this plant growth promoters as well as other bioproducts. Now, I must say that we have already done a very scientific way of approach, where we have checked the grain quality, and there is around 28 to 42% of protein improvement happened because of usage of these products. Now, there is also carbohydrate increase, which is around 40 to 68%. But largely, I would say that from a very nutritional side of it, as well as the yield and food security side of it, this particular bioproducts have been really promising based on our experience. Now, this also improved nutrient uptake and utilization in cereals, and this has also led to this entire protein as well as carbohydrate increase. So thereby, what is happening, we are creating a kind of a conducive environment to the biome to play its role, thereby improving the soil health and making the plant be a better, having a better health. The third one is about, again, since there is a nutrient availability is there and the farm plants are being more healthy, so the dependency on chemical fertilizer has also been observed, which is around 15 to 20% in our geographies, and the scale at which, based on what kind of a scale I'm talking about, is around 10,000 acres across 5 states in multiple cropping systems, be it rice, wheat, and rice maize system. Now, I'm sure everybody in this benefits of soil biological products, we see three areas. One is environmental, where carbon emissions reduction and improved water retention and biodiversity conservation. My panelists have already highlighted, we can't just only focus on carbon or water on only soil, but also we have to equally focus on biodiversity. Hence, there is a direct benefit of soil biological products being used in terms of biodiversity. Now, the economic benefit is that, again, this is leading to farm profitability because of the increased yield or reduced usage of inputs and thereby cost of cultivation saving. There is an enhanced market value for a produce. Why? Because it is more healthy. However, we have to solve quite a lot of problems or challenges in this entire market value for the produce, but it looks promising. Now, coming to the societal, there is a improved livelihood for the farmers and improved food security and reduced pesticide exposure is what we could clearly see a connect. The challenges, yes. So one is that, as Mr. Mark as well as Raj has already highlighted, we have to really look at these challenges as in a whole system or whole holistic way, where lack of awareness as well as adoption among the farmers. Why? Because again, in the entire question is that affordability plays an important role in the Indian farmers context. We have small land holdings, farmers not ready to or not geared up to invest alternative sources of other than the synthetic fertilizers. So, and policy has to be aligned according, I mean, as per the need. So, and so it's a kind of a everybody has to play in and they have to play their role. The second thing is, again, what we have also observed is that there is a lot of noise around these products. So everybody, especially from the product side, there are a lot of taller claims, but and there are also quality issues. So we have to really regulate it in terms of quality control, so that farmers and the ecosystem is positively benefited by these products as well as the increased market. And third is that this is the entry barrier, where we see that it's a high initial cost being there. So we have to really work with the entire all the stakeholders in the ecosystem, be it researchers, be it market, be it farmers, be it with the development sector, as well as the policy initiatives, which have to look at it holistically and then come together to solve it. Now, the opportunities is that, yes, government support has already been, and BIRAC as well as DSE as well as the government of India has been very proactive, and they have come up with a new policy on this, so which is really encouraging for all of us. And there is I think there are good number of products as well as the advancements have already happened in terms of research and development. But in the Indian farmer, in an Indian soil structure base, there should be certain more efforts with regard to research and development, and we have to really put efforts in terms of the entire market expansion. So this is where, so what we can offer to the startups who are here. So our efforts has been that we help these startups to pilot and scale the integration of these soil biological solutions across multiple states. And it is going to be a very scientific approach, where we are going to have a proper testing solutions in different crops, real time on the farm with the farmers. So thereby, I'm sure for a startup, this is going to be a great validation in terms of creating evidence for their own products. Now, and second is also we help whatever based on our soil health assessments. We do chemical, physical as well as biological properties. So based on the biological properties assessment of soil, so we also help them to come up with the formulations which are very distinct to crop as well as geography specific. Now, we're also working on this entire biojar based solutions internally to improve the soil health, and so that if a few startups are interested to take this forward, we can even help them to come up with certain kind of solutions. Our takeaways: cost-effective solutions. Focus must be on cost-effective products. Why? Because it's about cereal cropping system, which is largely predominant in the country. So thereby, it's a low value crops. Hence, you can't have higher cost in terms of products. Now, ease of doing has to be ensured. What we realized is that there are multiple solutions which are foliar spray and everything, but it has its own limitations in terms of ease of doing, and farmers find it, I mean, they're resisting, they find not okay with it. Why? Because that includes additional cost for them in terms of application. And it has to be time efficient, integrated applications into sowing procedure without extra time. So, I mean, we also see a kind of ease of doing has to be protected. It should be easy. It should be time efficient. Hence, if farmers typically look at it, some solutions which are going to be part of a sowing procedure without extra time being invested from their side. And again, the other one is about labor saving, which it reduces the cost of labor cost as well as skill demands. That plays an important role, and farmers are very much particular about yields. So you have to address, or your product should not be having a yield impact. If it is yield impact negatively, then there are challenges in which farmers would not be ready to adopt this. And again, apart from that one, this is also a key aspect. What we observed is about that visual indicators should also be positively aligned. Sometimes the grain quality as well as the productivity, everything has been fine, but the visual indicators are not really very much positive for the farmer. I mean, whichever is the agency which is facilitating it, they jump to conclusion saying that it is not working out. So we have to take all of these parameters when we are launching a product, when we are introducing a product to the farmers, so that the scale is possible. I think I'm done with it. Thank you.
Thank you, Suman. That was terrific. Next, we are going to be calling Mr. Ravi Tanetti. He is the CEO of the BEST, the Foundation for Bengaluru Science. Ravi currently leads a science and technology mission out of the Office of the Principal Scientific Advisor of the PMO, based out of Bengaluru, in which he enables the application of science while building networks among institutions, industry, policymakers, government and startups to create social impact and economic value. Ravi's previous assignment was at Bengaluru-based business services company as a CEO, capacity building, where he was involved in training more than 1 lakh of rural youth to get formal employment within corporate India. So we're very excited to have Mr. Ravi Tanetti here. Ravi, over to you.
A very good afternoon to all of you, and my special thanks to Bairak and Dr. Amita for organizing this wonderful event for us, and my co-panelists for being part of this event. Thank you all. As the Bengaluru Science and Technology Cluster, for us the Agri-Tech and nutrition is one of the critical themes, and there are some of the programs that we fund ourselves. So that is the importance that we attach to this particular theme. And it's only relevant that we discuss this today with this set of panelists and this audience, and see how to execute some of the operations that we already currently are running in a more efficient and effective way. So quickly, this is the overview of the Indian agriculture industry. We are 50% of our population is engaged in economic activities related to agriculture. We produce 7% of the global agricultural produce. 86% of our farmers hold land holdings of less than 2 acres. So they're all marginal and small farmers, and therein lies the problem. So what are the challenges that we currently face in the agriculture industry? Obviously, these are the problems of disaggregation and lack of scale, right? So when there are so many farmers, 150 million farmers, handling 2 acres of business, putting up any process or putting up any initiative to such a large population is very, very difficult, because the crops are different, the geographies are different, the soils are different, the entire the farming cultures are different, the languages are different. So it's very difficult to standardize this entire initiative in such a disaggregated industry. So what are the challenges that occur out of a disaggregated industry like this? Obviously, the produce is low, the yields are low, the capital of the farmer is very low. So he has to sell the produce as quickly as possible, because there is no cold storage for such a small quantity of produce. So these are some of the problems, and there is no way the farmer can value add his products, because he doesn't have the capital to put up a small factory or put up a processing unit, right? So when we see these challenges, the solutions are also at hand. And those solutions are related to collectivization. The moment we bring together the farms and the farmers into a larger producing organization, right, most of the issues of lack of scale will then become mitigated. So when the moment we collectivize, the yields and produce increase, the input costs come down because now you're buying a larger quantity through a systematic mechanism. We are having more bargaining power because there is the amount of, well, the volumes are much larger. And of course, you also have capital. We can produce enough capital to create value addition. And we can not only depend on the local buyers, we can go beyond the local buyers into the non-local buyer capacities where the costs may be, where the prices may be higher. The almost all the problems that I have noted so far have innovative solutions, and there are startups and innovators who are working on these problems. So broadly, if I have to divide the problems into 5 pain points, one is the, as I said, the volatility of the input prices and the suboptimal input selection, the varieties of input, whether it's seed, whether it's feed, whether it is insecticides, pesticides, whatever, the input parameters, the volatility is very high currently because of the disaggregation that has happened. There is limited access to technology and efficient cropping because the ability to buy farm machinery or to buy innovative products is not resting with a single decision-making authority, but multiple small farmers. The third is the uneven quality and lack of scale, which we already mentioned. And the post-harvest complications of, spectrometry, of being able to grade products, of traceability, right? These are the issues that come post-harvest, supply chain logistics, cold storage, etc. And of course, the lack of financial solutions. There is no credit availability. There is no capital availability. So things do become very, they're all on a lending basis constantly. And if you see the innovation capacity to solve some of these problems, it adds up to a wonderful pie of about $24 billion. So that is the economy that lies ahead of us if we can somehow aggregate the innovations and bring them to efficient applicability. So $24 billion is a huge industry, and which is why we see so many startups and so many organizations getting their feet wet in this industry. As a cluster, we ourselves work with more than 70 to 80 kind of startups, and our focus, because of our lack of width, our focus is largely on, say, innovations which affect efficient cropping. For example, we work with startups which are having pheromone-based bioinsecticides, nano fertilizers, right? Irrigation as a service, smart soil testing solutions. We got integrated nutrient management companies. We have IoT-based fertigation systems. We have moisture and crop systems, and we have low-cost machines that can seed, weed, spray, and plant, right? So efficient cropping is something that we are working on. We're also working on innovations in farm inputs, which is whether seed breeders or precision weather apps. We are working a little bit on the farm inputs. We're also working a little bit on the innovations in the post-harvest and supply chain, whether it's cold storage, whether it's gate-to-plate apps, whether it's biodecomposition of stubble, or low-cost machinery which can harvest and thresh. So we are doing a bit working with startups which can improve cropping efficiencies, which can improve farm inputs, and which can improve the post-harvest issues. We are also doing a bit through research. So we are doing funded research for many of the problems that the farmers face today. Some of those innovations include smart polyhouses. It includes UV imaging methodologies. It includes transpirometers, crop evaporometers, right, which can actually measure real time the amount of moisture escaping from a crop or from the soil. We also have leaf mimics, which can actually simulate the evaporation from a leaf, right? Thereby knowing how much irrigation needs to be done so that the water is not wasted. So we have We are working on those sensors. We are working on pheromone-based attractants, insect attractants and insect repellents. We are also working on something which is quite, transformational in the drone industry. We're working on creating a drone delivery system where you can actually control the size of the droplet, whether it's a nutrient or it's a pesticide. We actually can control remotely the size of the droplet so that we do not overspray or underspray, or we don't waste pesticide or nutrients. And this is actually one of the underpinnings of precision agriculture that we are funding. We have discussed so far about the innovations that are available in the market, and there are many, many more innovations, and there are enough startups in the country on agri-tech. And the research that we're doing is only going to add to that. But where will all these startups work? Where will they go in order to synergize their innovations on the field, right? And now we have to look at what is on the demand side, the supply side of the startups and the innovators. On the demand side, we have the FPOs, the farmer producing organizations. There are typically about 10,000 FPOs in the country, right? And a brief distribution of those FPOs is given here. If you see UP, Madhya Pradesh, Karnataka, Tamil Nadu have a high density of the farmer producing organizations. Typically, the farmer producing organizations are collectivizers of farming communities. So each FPO has about 1,500 to 2,000 farmers working for them. They're actually the shareholders, and the FPO can be a cooperative, it could be a company, right? And the farmers, actually the capital of the farmers is used by the FPO to procure the inputs, and the produce of the farmers is used by the FPO to sell to the corporations or to the APMCs, right? So basically the FPOs are the inflection points. They are the convergence points where the farmers' interests and the market access are both converging. And that's where the FPOs become very important for us to actually execute the intent of the agri-tech industry. We need to use the FPOs to adopt some of the technologies that suit them and deploy them on the ground and do the impact analysis with the FPOs. And that is a recommendation that we are trying to make here. What FPOs achieve is they collectivize, they give market linkages, they give information exchange, which is very, very critical. They give stability of rates, and they give superior decision making to women, right? These are very, very immensely important aspects of the farming community. And what do FPOs need? They need capital, they need capacity, they need credit, and they need consistency, right? Consistency of policy. Capacity is ability to adopt technologies, getting trained on technologies. And of course, capital, they need money, because it can't be only shareholders who are farmers whose money is being taken. So they need some kind of capital, right? And credit, of course, there are credit agencies, but the documentation is so heavy that many of these credit agencies do not end up giving loans to the FPOs. And this is my last slide, in the sense that how do we bring all this together? So we have startups, we have a demand from the farming community, we have an FPO convergence, and we all know the intent and mission of the industry and government to actually transform this industry, the agri industry, right? So all ecosystem partners are willing to look at transforming the agri industry, right? But until unless we do these steps, the intent will remain as an intent, right? So I have suggested 4 initiatives. One is the FPO initiative. What I'm saying is that let us choose maybe on a ratio of 1:20. Let us choose FPOs who are representative of certain agricultural practices, whether it is crop zone, whether it is soil profiles, whether it is a geography. Let us take representative FPOs in a state, So if in Karnataka, for example, if there are 400 FPOs, I can pick up 20 representative FPOs who can actually cover for all the 400. And then we can have quarterly meets with them where we plan the sowing plans, we plan their sowing, we plan their irrigation, we plan the technology to be adopted, and we also plan for the soil health status and how to make nutrients for that particular soil. And we have, as I said, startups and companies which can do all of this. We have them at hand. Then we also discuss the credit availability, capital availability, and then what we review them on is how much of value addition have they created, right? Have they been able to get higher prices for their farming community? With taking all the help from us, have they been able to create more shareholder value for their farming community? And have they been able to create a value addition in terms of food processing, in terms of traceability, etc.? So that is the FPO initiative. The technology initiative, which I spoke so far, is about creating a repository of all the technologies available and constantly update those technologies quarterly with new startup validations which happen through bodies like BIRAC, etc. And then keep a rate card and probably an impact analysis of all those startups on the platform so that the farming community can understand what works for them and what are those startups that they should work with. And that can happen through the FPOs. So we create a technology initiative. And the third initiative is the industry and government initiative. There are huge gaps between what actually is envisaged and what actually happens on the ground. For example, the tax structure, right, is different when the FPO procures and when a corporation procures. The tax structures are different. Some claim GST, some do not claim GST. But FPOs, being a companies, right, have to claim GST. So their procurement prices will obviously be more, right? They cannot deal in cash. So these are issues which we need to resolve at a policy level. There are, we need to bring a parity between in the fertilizers and in the pesticides, etc., across the distribution chain, so that the dealer of a fertilizer does not give a greater discount than what an FPO can when procuring in mass, right? So there has to be a parity in the distribution channel. FPO should be treated as another distributor. The third is that we can we give better margins to the value-added products that the FPOs create? Many FPOs actually brand their own products and sell it in the market, but they do not have visibility because there's no marketing that happens for those products. So can we help them with that, right? And lastly, what I'm suggesting is that there are 8 clusters like ours in the country, and most of the 8 clusters can be probably given 2 or 3 states jointly, which works to about 150, 160 FPOs per cluster, right? And together with all the startups getting channelized to the clusters, we can have a single platform where the entire startup technologies are available with the rate cards and their impact analysis, and we have a whole set of FPOs who can buy or who need some of these technologies and some of these innovations, right? And since this is a principal scientific advisor's office initiative, right, obviously the level of government interaction or government infusion into this initiative would be very high. So these are some of the recommendations. Thank you for your attention.
Thank you, Ravi. Next up, we have Mr. Srinivas Karavari, the president of Inera Crop Sciences, the biologicals division of Absolute Foods. With professional experience culminating in critical roles as a P&L leader, MD, and CEO, Mr. Srinivas has had a 28-year career arc in agribusinesses, embodying visionary leadership, strategic depth, and a thorough awareness of the intricacies in crop protection seeds and traits. Across a variety of business activities, he's worked in a 10-year overseas assignment in Bangladesh, as well as other assignments across India's diverse cultural landscapes from north to south. So please welcome Mr. Srinivas Karavari.
Hello, everyone. Hi there. Can you give me some cheers that we always are still awake? Thank you. Yeah, my name is Srinivas. I had been in the industry almost like 28 to 30 years. Been with crop protection, agrochemicals, seeds and technology, and now a new journey had started in terms of shaping the biological agriculture and make it more sustainable to the farmers. The presentation is there. So absolute. This is what we are talking about. We have heard a lot about the challenges, the issues, etc. So I think I would more talk about how India is shaping up and how Absolute as a startup that actually, spearheading in the direction as suggested by eminent panelists out there. I'll take a pause and look back. 1947, we got the independence. By the time we started Green Revolution in 1960, by the time India had become self-sufficient with at least food crops, it took almost 25 years. So by 1974, officially we said we were self-sufficient in food production, not all other, I'm not talking about oil seed pulses, which we are still not. Then it take almost 25 more years to become an exporter of agriculture commodity from India. So this is what it took, and now that we are at a crossroads of food security and safety because the nutritional requirements are still not met to the larger Indian population. And we all know that this would be, a long way to go with that. So I'm just quickly run through what Absolute is doing about in the same spirit. So we are a startup of new gen agtech company focusing on across the farmer value chain, where we are talking about biological inputs, digital value chain, and commodity, so that we play across. And I'm not talking about Absolute Bio, which would focus on other aspects of biomaterial, sweeteners based of protein, enzymes, and all other bio pharma based applications that we are actually working upon. So I just covered this. We need a lot of food, a lot of nutrition. Our soil is almost like 24 billion metric tons is getting lost annually. Is going to be a key concern for us to be more food secure in the future. Water almost like 50% is runoff, and 10 million metric tons of carbon is getting emitted because of the new fertilizer that we use today. So how are we working as a startup? Because I will not take much time what we are doing because we are well invested startup globally now expanding with all innovations. I really looked at Dr. Reddy Foundation's Suman's presentation. A lot has been done from there. Something similar at a corporate level, what we are trying to do here. We have a nature intelligence platform which are exploring and preservation of the microbes, a lot of organisms that we are trying to from a different extreme parts of deserts, glaciers, etc. And then using them we are trying to develop the products that actually could help into the different areas that I just talked about, and building a high performance inputs biologically that is called INERA, the vertical which I had today, and then deep engagement of the farmers with retail centers, value chain. And also I'm glad to tell you we have the at least Asia's, to the best of my knowledge, the fastest soil testing machine which can give you results of 12 parameters as accredited by ICIARI within 20 minutes of the test, which is fully automated and very portable machine that we could develop. Eventually we are taking it to the farmers and then market. And Silk Route, I mean, post the production of the farmer, meeting the farmer requirements, we are actually doing the trading of the business, and we are one of the top grape exporters and pomegranate exporters from India today. And we are trying to cover everything. So this is the natural intelligence platform. I know the time is short, so I would not completely cover this, but I would leave the time to the rest of the panelists. One thing I would like to assure you is this is one of such startup where we are actually putting up together all the means and ways to find the solution. the challenges would still remain. We have about 15 crore farmers. As I said, we took almost 2 to 3 decades of every major step of this country. So balancing food security and safety so that we can actually save our food security for the future. The balance, the golden balance between the conventional way of doing things and putting up the modern techniques into it becomes very, very critical for all of us. With that, I sign off and leave some space to my next speaker. Thank you very much for everyone for being patient audience. Thank you so much.
Thank you, Srinivas. That was absolutely great. Sorry, bad pun there. But in all seriousness, we appreciated the presentation for being crisp and brief and to the point, and we hope for the same from other panelists. So next up, we have Dr. Murli Manohar, the founder of Ascribe Biosciences. He is a C-suite leader in the ag-tech and biotech space, poised for a role directing innovation, crop protection, portfolio management, or product development, and management to advance and sustain sustainable agriculture and biotechnology operations. In establishing Ascribe, he provided instrumental leadership from concept to execution and administered a multi-million-dollar R&D budget to transform scientific discoveries into disruptive market-ready products. He is well versed with engaging in industry leaders, academic researchers, and CROs. So thank you very much. Dr. Murli, please come join us.
have not changed it yet. Sorry, I think it's still the last slides.
Slide तो वहीं पे है, इससे चेंज ही हो रहा है ना वीडियो है कुछ बढ़ नहीं रहा मैं उस पर देख पाऊंगा
I can speak without slides. They're fixing it. Oh, here it is. Wonderful. Thanks, Mark. Hello. Good afternoon, everyone. Thank you for the introduction, Mark. I'm very glad to be here and honored to be invited as a speaker. So thank you, all organizers. I would also like to take this opportunity to just congratulate BITEC team. What a great event here and providing forum for the discussion on the future of biotechnology. as Mark was saying, there is talented people leaving India. Perhaps I was also from IIT and went to USA, did my PhD and stuff, and I'm hoping to come back. I'm working with the Virec team, and hopefully there's an opportunity to come back and do some work here. My background is in biotechnology, say mostly around the agriculture biotechnology. Um, and I love working in the agriculture sector because the theme here is food security, and I can't think of anything else that's more important than agriculture for the food security and climate and everything else. And agriculture was not random for me because I belong to a farming family. My parents and grandparents, they were farmer. I helped them in their farming operations until they left farming because of all the challenges with the farms, right? And then, all the resources was not available to fix those problems. So here I am, a farm boy from the farming all the way to entrepreneur, trying to fix the same problem we faced early on. So before I get to the talk about the Scribe Bioscience, the technology that we developed, I would like to just talk to my friends, entrepreneurs here, how the journey from starting a company to get to the commercialization over the line. And, the larger companies, they're great in developing things. They are great in just keep doing what they do, but usually the disruptive technology comes from a startup. And startup is, it does feel like you are jumping from a plane, jumping from a cliff, and you're making plane on the way to the sea. If you can't, then you'll fall in the sea. So it did felt like that, and perhaps some of you who are entrepreneur can relate. And the other thing, if you are working in an organization, you probably have a manual to follow, right? For the startup, there is no manual. You are learning every day, and you keep going. And there is this saying, right? Better safe than sorry. I mean, if you have been to a management training or worked in a larger organization, you are inherently risk averse, and a startup is anything but risk averse. So better sorry than safe. You tried. You may fail, but you tried. And one of the key learnings through the process was, working with the customer, understanding what they absolutely need, and then work your way backward is the way to go. Not the have a fantastic technology and you don't know who's going to use it. And work for the impact, not for the valuation. If you are developing something that's outstanding, the valuation will come. And I think we have all, when we start the company, we felt like we start the company and it worth little today and perhaps $1 billion in next few years. So we have all done that. So the idea really is work for the impact, bring the value, and the valuation will come. And if you're in a startup and if you're developing a disruptive technology, perhaps the good idea is to think about, you do something that makes the old technology obsolete, right? At least 5 to 10 times what we already use there. So that's a little bit of my journey and something I learned during my entrepreneurship process. And I'll move to what we did at Scribe. As Mark said, I was one of the co-founder and the former CTO. Last month was my last month in the company, and I'm moving to a different company, starting different company. So we'll talk about what we did at Scribe and some of the learning we had on the way. So we are a group of researchers at Cornell who work on small molecules, and we're trying to understand how these small molecules regulate the physiology and use those small molecules that interact with other organisms to develop as a drug or agrochemicals. And what we know about the small molecules, this iceberg is a good example, right? You see the iceberg and you know that this is how much exists, but in reality, it's a lot under, right? So what we know about the small molecules found in organisms is perhaps 5%, perhaps 2%. So a long way to go. So tens of thousands of molecules are waiting to be discovered and to be developed as an agrochemicals or different drugs for the human users. And we use an approach called comparative metabolomics. What is essentially is you have two organisms and you compare their whole metabolome, and you identify new molecules, and then you link that new molecules to certain characteristics, certain physiology, certain phenotypes, and then you use that molecules to develop technology that can use to treat disease in humans or an agrochemical in plants. It's a very sophisticated process. It's not very simple. And with two of the researchers at Cornell, I'm part of that. It's I think we are one of the world's best to do that. And so, you know, when we did the comparative metabolomics, we see that there's a new molecules out there, and there many things could be done. And in that process, we found that some molecules that's particularly produced by the organisms that interact with plants. And then we found that these molecules do something to plant that could be translated into a crop protection product. So the question number one was, is there a need? Is there a pain that farmer is facing that we can develop something for them? And of course, this is, the plant pathogens or pest has become the major problem. So the molecule, a set of molecules we identified, it's a different molecule than things were out there. It is, we call it vaccine for plants. See, you go to hospital, you get the vaccine, you go home, you're fine. A month later, 2 months later, when you get the infection, your body just responds faster. That's the concept of vaccine. And a similar word we use in plants called priming. So we apply this molecule to the plant, and plant does what they do, and they go by their life normally. But when the pathogen comes, they just respond faster. So in a way, it's the word is priming, but we call it vaccine for plants. And the one of the challenge for any biological technology is everything looks great in the greenhouse, but we go out and try in the field, it fails. 99% of the time, it's bound to fail because now you are going from a very controlled condition to not any controlled condition. But we were lucky there. This technology actually worked really well in the field. So this is one of the slide here shown in the wheat against the Fusarium head blight, one of the major pathogen in US. And the protection was as good or better than the synthetic chemistry at that time. And then we expanded the trials to multiple crops, corn, soybean, rice. And just last year, these trials were done in US and the neighboring country. Just last year, we found some contractors here in India, and we're trying to test here and bring technology to India for Indian farmers. So, for any technology, multiple hurdles to meet before you actually commercialize it. And field performance was the most important, right? So once we had that, the farmer adoption, anytime you have new technology or disruptive technology, and especially if it's coming from a biological source, there is a term in US called snake oil salesman or bug in the jug. So they are very skeptical of any technology that's coming from the biological source. So our approach was, we went to the farmers, right? We talk to the farmers and ask them, hey, you try, here is a technology. And one thing I noticed, right? When I told them that I'm coming from a small company, nobody paid attention. When I said I'm coming from a Cornell University, now you have their attention. So that's how I got them, many farmers to test. And they all were very excited about that. And there I wrote the testimony for us. And that testimony was very powerful. We went to federal agencies and our investors, and they liked it. And that's how we got the federal money and the investment. So, and then affordability, of course, we came a long way from many $100 per acre to now perhaps lower single-digit dollars per acre. And safety, you have to get through the safety to use it. So after checking all these boxes, just last year we filed the dossier to EPA in US and other countries for the regulatory approval. And we signed first commercial agreement with a company called Nutrient, major distributor in US for commercialization. So that's in US and North America. We have also been working with the partners in Brazil and India to commercialize in these other countries. And I think what is most critical to understand here is biotechnology research is not easy. It's very expensive, very time consuming. So I just wanted to emphasize here, even with the best team we had, best researchers we had, it took us 10 years to make sure that this technology actually worked. Those two gentlemen here is Dan Klessig and Frank Schroeder, one of the best in the world in plant pathology and natural chemistry. So these are some of the questions that the biological or biotechnology-based products are facing in general in all countries. And for me, if you can show that it works in the field, then the regulatory becomes a nightmare. Anytime you're bringing a disruptive technology, the regulatory agency has no idea how to deal with it. And if they don't know how to deal with it, it might take years before they approve it. So that's quite a opposite of sustainable approach, right? You want to bring those faster. So that's, I think, is the one roadblock. I think the regulatory agencies has to come together and develop a coherent plan that the technology is developed in US can also be used in India or Brazil faster than what we have today. And what we want to do with this is, now today we apply this toxic fungicide kilos, our friend panelist was saying, we want to go to the future. We want to use the natural technology that works by activating or improving plant health. So as I said, I moved out from the scribe and working on a different technology. And we are developing, there's a team in US that's developing a crop protection technology, a synthetic biology approach, where you can modify an organism to produce molecules that would target different pathogens at the same time. It's like aspirational stage at this time. We have done some early experiments, but this is where we want to go in next 5 years or so. And again, thanks to Global Bio to invite us. Last night, IIT Roorkee group came together, so there was a great reunion. So, this is an opportunity to meet your friends as well. So with that, thank you so much. I'm here to answer any questions you have. Thanks, Mark.
All right. Thank you, Dr. Murli. Now we have Dr. Neha Avasti, the project leader and domain expert at the Biosensors Institute for Molecules and Materials and One Planet Research in the Netherlands. One Planet is a multidisciplinary collaboration between Wageningen University and Research, WUR, Radboud University, Radboud MC, and nanotechnology world player IMEC, supported by the province of Gelderland. And it is only because we've had so many Dutch investors in Omnivore that I can actually pronounce these words. Within One Planet Research Center, we develop game-changing innovations towards a society where people lead a healthy life with access to healthy and sustainable foods. Dr. Neha's goal is to strengthen the partnership between Radboud University Faculty of Science and the One Planet Research Center on key topics within two themes: precision health, nutrition and behavior, and precision agriculture, food and the environment. So without further ado, Dr. Neha Avasti. I think you have a clicker, yes. We actually have a presentation.
Yeah. Thank you very much. Thanks for all those who stayed back. I'll try to be very quick. It was 7 minutes in the morning, but let's see how it goes. I would like to thank Bairak, Dr. Amita Joshi, Dr. Kumar, all the team here who've organized this, and also to my colleagues at the Dutch Innovation Agency, Minbuza. Thank you very much for that. Very happy to present what we do. I come from One Planet Research Center, and at One Planet Research Center, we work at the crossroads of agriculture, food, healthcare, and environment together with digital chip technology. And our goal is to tackle the massive challenges we face in the society and create sustainable solutions that can help you have a better life. If you think about it, a healthy life is determined by the food you eat, the environment in which you live, and the type of healthcare that you have available. Oh, I'm sorry, I'll go back. This is how the center is constructed. It's a very unique R&D hub in the eastern part of Netherlands. You can see on the yellow side of the map on the top a star. Although Netherlands is a small country, we still have east and west and south and north. And this is close to the Dutch border in the province of Gelderland, which is near the Rhine area, which is a very fertile area for crop and agriculture. The consortium consists of 4 partners: Wageningen University and Research, which is one of the top universities in agriculture and biotechnology of the world. We are physically located in what is known as the Health and Food Valley of the Netherlands. IMEC, which is a digital and chip giant based in Belgium, an R&D hub which has created innovative solutions for many years. Radboud University and Radboud University Medical Center, who help us in fundamental research that is connected to more healthcare. The overarching goal of our program is to create novel sensors and digital twins that help us make predictions and enable precision agriculture and food processing. We also have a healthcare team, as I said. I'm not talking about that today. So what are the challenges that we face, which sort of drives and motivates us to do the work we're doing? A lot of has been discussed already in the talks before me. So this is a summary for those of you who were not paying attention. We have a growing population of the world, unexpected climate change issues, erratic rainfall, for example, widespread use of chemicals and fertilizers that has depleted the resources we have. We also have what is very relevant in European countries right now is depopulation of rural areas, which we call rural aging. And if you do any type of AI or data analytics, this is also known as loss of expert knowledge, because what the farmers were doing since ancient times, developing their own knowledge and database, and we will lose that if we don't have educated farmers to take this forward. So how do we address these challenges? One way to do that, and this is the concept around which we do our innovation, which is inspired from what was Industry 4.0 some years ago, which said that machines would help you make any process very efficient. We now look at Agriculture 5.0, where we believe that you create value by combining human knowledge and machines together to lead a sustainable product systems and process systems there. And in this concept, we work with four ideas. Autonomy, which means that you want intelligent systems such as smart greenhouses, smart climate steering systems. Biology, where we want to have sensors that interact directly with plants and listen to what plants have to say. For example, the pH, the quality of sap which is present in a leaf. Collaborative agents. So we believe you should work with cobots, not only just robots, with human intervention, which will help you sort of tackle the challenge of reducing manpower. And something very different and challenging is about decentralization. You don't need big hubs to create this. You can have a local and modular system of agricultural units that help you supply in a sustainable way in an urban setting. So irrespective of where you live, you would want to have organic, fresh food on your table at a very reasonable price every morning. And whether that is coming from 500 kilometers away or 2,000 kilometers away is something you have to think about if you want to be more sustainable in the future. As a digital sensor-based organization, these are some of the solutions we have developed. We do a lot of environmental monitoring, which is extremely relevant for sustainable agriculture. As I mentioned some of these, I'll skip through that and show you just a very quick example. This is one of our sensors which is used to test the ripeness of a tomato. It was already discussed that a lot of food is wasted in supplying and not delivering it properly. Tomato is one crop which is extremely sensitive to the time at which you harvest it. And so we have this RF-based sensor device which is being used in a lot of greenhouses, and we work with farmers to test these devices. The second sensor is a leaf monitoring solution which helps you look at any insect or any pesticide effect on leaves very quickly, sort of based on hyperspectral imaging. This is just another very quick example to show that sensors work in all domains depending on what type of problem you want to solve with them. They could be invasive, they could be non-invasive, they could be image-based, and we not only develop them, we also validate a lot of these sensors across the agri-food value chain with the stakeholders that we work with. This is, the movie works. So this is one of our cobots, which is used for pruning and harvesting. This is being tested in the Wageningen University campus. So to summarize, the innovation concept that we work on is we still come from a very fundamental science perspective, working with sensors. We collect a lot of digital data, which needs to be analyzed very carefully. We go back and apply the knowledge with the sensors that we have, but we then come back again and improve our sensors. This is how the cycle makes us at the center as an innovation hub. And we heavily benefit from the fundamental science that is done by the public universities, the two partners that we have, and as well as the regional stakeholders, all the food companies and agri companies which are present on the campus. We also play a very important role in translating the fundamental research from the campus to the market. Some of the thoughts from our innovation journey, I think I heard in one of the talks that you could learn from what is being done in other places. I would just share this and leave it for you to learn and ponder and adapt. I think the challenges are very global. The solutions have to be local. Solutions are extremely complex. And you need to think about how many layers you need to understand before you can bring something to the farmer or to the field. You cannot go without the leverage of digital technologies. That is very, very important. It's like our toolbox, which should be used smartly. You need to build partnerships that work together. You need to understand the role of human potential. So the second half of the room, basically, because you need to train students and teachers and farmers, everybody about the technology that you want to bring in the market. If the operator does not know how to use the machine, the adoption of that technology is extremely hard and often inefficient. And of course, you have to keep sustainability in your mind. With this, I would like to summarize what we've achieved in the last 5 years. We've been funded for 5 years by the province of Helderland. As you can see, we've had 30 PhD students who came out, 46 patents, 33 funded European projects, which got us something around the ballpark figure of 30 million euros that we raised ourselves, 600 students in open education programs. This is the most interesting part of our work. These are students who go to what would you call vocational universities or polytechnics in the Indian concept, who train to become farmers or tractors or operators. And we work directly when they are studying with them to introduce our technology and our interventions. These are some of our private and public partners, which have been together for many years. This is just the food area. We have a portfolio in the health area as well. And with this, I will leave you with a very interesting thought. The chip revolution that came 50 years ago with the silicon technology brought us to this day where everybody is hooked up to their cell phone. You cannot leave it even when the talks are going on. And I challenge you that in the next generation, chip technology would be the way that will help you somehow take care of many of these challenges in agri, food, and health sector that we have. This brings me to the end. And I would like to thank the team at One Planet that supports my work, and also leave a little thought there for you at the corner. The best biosensors that you can get will actually come from nature, inspired by nature, combined with the digital solutions we have. Thank you.
Thank you, Dr. Avasti. I'll go ahead. So we have a special guest today who has not been on the dais so far, and this is Dr. Yolisa Pakela-Jazile. She is passionate about development and deployment of appropriate technologies and skills for thriving agribusinesses, particularly in rural communities. She has spent much of her career in the Agricultural Research Council, I believe in South Africa, or not. I didn't get a proper introduction. Pardon me? Oh, of course. No, I was going to turn this over to you. I was just introducing you. Where she promotes opportunities presented by scientific research and technological innovation. So please, everyone, we look forward to Dr. Yolisa Pakela-Jazile speaking to us. Thank you, madam.
Good afternoon. Thank you for this opportunity on behalf of South Africa. So the Agricultural Research Council is the R&D arm of the Ministry of Agriculture and the Ministry of Science and Technology. So we have developed, over the years, we have developed technologies that have made agriculture one of the thriving sectors in our country. We export technologies and products globally, but we still have challenges which have been mentioned here, especially on developing the agro-processing sector, as we export a lot of our raw materials from gold, diamonds, to food products. And we import a lot of food products from other countries. So our biggest challenge that we are hoping we'll get partners for is the development of our agro-processing sector. And we have noticed that India is a global player in entrepreneurship as well as management of smallholder farmers. So back home, we have roughly about 30,000 mega farms that provide food for everybody. But we have about 1 million, potentially 20 million smallholder farmers that we are struggling to bring together to provide resources so that they can contribute and grow our economy. So we are looking to India for partnerships, and I'm very happy that I could also see who we can partner with on the challenges that we have to make sure that the smallholder farming and processing sector contribute significantly to our economy. So I would like to thank Bayrak for bringing us here and invite the delegates to the International Pavilion to see what we do and how we can forge lasting friendships. I thank you.
Thank you, Doctor, for gracing us with your presence. Please, we have some seats at the end, or you can just take mine. Honestly, don't make the journey. Just have a seat. So, if at all possible, I'd love to get the slide that my deck back loaded up for a second on the questions. Is that possible? All right, I think we're just going to ad-lib this. So this panel has gone on very, very, very long. And we want to make sure that we kind of end with a bang. So I think what I will do is throw out some questions to the panelists. What I would firmly, humbly beg is that not everyone answer every question. Okay? So we're going to think of some interesting questions, which I'm going to do off the cuff because we can't see the presentation that I made. And let's actually start with oh, here we go. Great. Okay. Save me. Okay. But I want to kind of do something a little bit different. So Srinivasa, maybe we'll start with a quick question for you. Biologicals in India have grown from a very small base, but by no means to their potential. What do you think is required in the next 5 years, not the next 20, for them to reach their potential? And what is the degree of that potential? And you have 1 or 2 minutes to answer this.
Sure. Thank you. So, one, biologicals, everybody knows that so far the conventional things that are delivered in terms of food security with synthetic fertilizers, pesticides is something which we already delivered whatever we could. But for the last 3-4 years, we had already seen the kind of pest outbreaks. The available crop protections are already developing resistance. The new chemist is already gone resistant. Many populations are not getting controlled. So integrated nutrition and pest management is the only way to move forward, which actually becomes biologicals comes into picture, not just biocontrols. One on, I think if you look at the food subsidy, urea subsidy bill, I mean, in India pays a lot. And we have 20 to 30 years of nitrogen and other elements are available in that. So biofertilizers can play a vital role, which farmers are already getting. Mycorrhiza is one best example, is already being talked about the next to DAP. And biocontrols and mixing of those into the overall pest spray schedule becomes very relevant for it to make it more integrated.
Okay. All right, that was to the point. Now, Dr. Manohar, and so I have a question for Dr. Manohar and a question for Dr. Avasti. Dr. Avasti, you're based in the Netherlands, right?
Yes.
Dr. Manohar, you are based in Ithaca, right? More or less, upstate New York. Cool. What do we have to do to get life scientists from India to move back to India, as opposed to living in Europe and America, where your talents, while I'm sure much appreciated, are less critically needed? What do you think is required? Why have you built your careers to a great extent outside of India? What drove you to do that, and what would you want to see to come back? Please, each 2 minutes. So let's do this lightning round.
I'll do it in 1 minute. I think innovation is very transdisciplinary. I am not a life scientist. I studied physics. My PhD is in physics. If India offers an ecosystem where you can work across the boundaries of your discipline, and as a student, piche wale padhega India people, if they understand today that whatever they are studying, irrespective of that, they could be successful in another field, I think you would have all the right people here. So
Okay, so just interdisciplinary approaches, right, as opposed to the silos that currently exist in our university.
I think bottom up interdisciplinary, from education till knowing your career options.
Fair enough. Okay.
I'll just follow up. So I didn't know much about the resources India has until I met Barrick people a few months ago. I think they are going in the right direction. What they are doing support biotechnology. And Mark, so we were talking outside. I am hoping to come back. I'm working with the Barrick team. I started a company with a team here in Faridabad. So I think the resources, every disruptive technology needs, or every scientist need, is to cut the red tape and get through the experiment research real thing faster, which I think is going great here. Barrick is doing a great job here. So I think there is an opportunity to come back. I hope I'm coming back, and maybe more people who learn about the DBT and Barrick programs, I think it's in the right direction, and that will happen, I guess.
Okay. I think that was a good answer. Now, we've got Ravi. Okay, Ravi. I'll tell you something that drives me crazy. Okay? Every time I suggest that the government of India just focus on Bangalore as the life science hub, somebody wants to argue with me about it. They'll argue that it was Hyderabad, but that was true a long time ago, and more for pharma than kind of the future of life sciences. Or they'll say that Delhi is the capital, right? Or they'll point out that there's good chemical research in Pune. How do we drive Bangalore as the place for life science talent in India, and how do you get the support from all ecosystem participants, despite the tendency that exists, right, in the bureaucracy to want to spread everything across the entire country, which is a good public idea, but not how agglomeration economies really work?
No, it's not an easy question to answer in the sense that there are issues in Bangalore which everybody knows, but taking from what Neha has said, the richness of transdisciplinary sciences that Bangalore carries, I'm not sure any other city in India does. Right? And the second is that whether we like it or not, it is the startup capital of the country. There is, I mean, in more ways than one. One is that it's got a lot of money, liquidity floating there. And second is that there's a huge ecosystem of intelligent people, right?
Yep.
Very knowledgeable people, people who have stayed abroad and come back, people who know, how technology works, right? So I believe that the basic ingredients of life sciences capital are already available in Bangalore. What was lacking was probably the government initiative, but that has now come very strongly. A couple of months back, I was attending the state brainstorming session on creating what is known as Kheer which is basically a life sciences campus dedicated for biotechnology just outside Bangalore. Right. So I believe that the government is also now stepping in, and it's only a matter of time because before Bangalore actually becomes one of the competitors.
No, that's great to hear. Okay, so some kind of pointed questions. Shuman, you're based in Hyderabad. That's the rival biotech hub, right?
Right.
Tell us why Hyderabad's better. And the logic of focusing on Hyderabad, or how Hyderabad and Bangalore differentiate each other from a life sciences ecosystem perspective.
Okay, so let me come from my own experience. I lived in Bangalore, I'm living in Hyderabad.
Okay.
Okay, so first thing is that the disadvantages of Bangalore with regard to certain kind of infra and everything are now, because they have learned, they have started early, so they have had their challenges with regard to Hyderabad. They have learned it and they don't want to get into the same thing. So that's the positive side of it. Yes.
Yep.
So probably the second option as part of this life sciences or a biotechnology related thing, I think Hyderabad is better suited. That, I mean, compared to, what you call Bangalore. Why? Because there's already pharma, biopharma, health capital, all those aspects will make it a natural choice, is what I see as a some possibility.
Well, fair enough. Wanted to give the case. All right, now we have Dr. Yulisa. Do you have a mic? So I have a sort of outlandish question for you. Okay. If you were to drive one sort of major initiative between, for example, you are from the ARC, which is similar to our ICAR, correct? If there were one thing, one crop, one value chain, one approach to agriculture where South Africa and India could best collaborate towards mutual gain, what would be that crop and why? And what would be the initiative you would love to build? Maybe there's something already that's very strong, but if you had, $1 billion and you were putting it into one huge initiative, what would be that initiative that you think could be a game changer for both countries?
For South Africa, the one thing I would like to partner with India for is the very basic in agriculture, seeds.
Okay.
Seeds to first to increase our food base in South Africa and not to have so few food choices, especially crops. So I would single-mindedly pursue a project involving seed production, seed entrepreneurship, seed technologies, everything.
That's a terrific idea. All right. And last but certainly not least, we have Raj. And the question that I would ask for Raj, because I think the World Bank brings a wonderful perspective on policy and a level of policy advisory and a degree of independence where you can say things to the center that basically no one else can say. So my question to you, right, is from this only. What are the key policy interventions that you believe are required to build a sturdy agri-food system in India? But I don't want you to go on, I don't want you to say 10 or even 3. What would be the one policy intervention? The one policy intervention that if you could snap your fingers and the center would agree and every state would agree, trampling, of course, federalism, that you think would be the most impactful?
Great question, Mark. And I will buy the answer from what Neha said. We are moving into a situation which requires multidisciplinary thinking and multidisciplinary approach to address the problems. So what my expectation, since agriculture is a state subject.
No. I just gave you The
One
magic
call.
ticket.
So
It's not a state for one move. Imagine you're playing a game,
Yeah.
and for one move, it's not a state subject. The center has agreed, the states have agreed. You get to play one card that will change the system more than anything else. Please don't tell me it's multidisciplinarism. What is the one move?
So one word will be a multidisciplinary platform wherein people engage there at the central level. Say, in this event, I am missing the entire agriculture ecosystem, the Indian Council of Agriculture Research and state agriculture universities and all, who are the real actors. And the DBT is in a different silos. So we are working in different silos. How we can have a platform wherein we can start engaging, sharing knowledge, sharing what we are doing so that we avoid duplication and we converts there to advance the agenda of bioeconomy.
Okay. I would have gone with converting the entirety of the input and output subsidy system into DBT, wired into every PM Kisan account, and shutting down all subsidies on one side or the other. But cool, we disagree. If I'm going to play one card that I win, that's the card that I will play. But then I'm loud. So it was a great pleasure having everyone. It was a very long panel, so we appreciate all of the survivors that are here, that have stayed with us for this time. And please enjoy the rest of the conference, and let's give a hand to our fantastic panelists. Thank you very much, everyone, for coming. And thank you so much to everyone from BIRAC who helped make this panel happen.
Thank you all, as he said, the survivors for being here and listening to this wonderful panel, because this was a mix which we planned because we wanted to get the perspectives, and I think the panel and the moderator has beautifully delivered. Now we would like to thank them all. I would like to just thank them by giving them mementos from BIRAC. Please bear with us for some time. I am doing both the jobs, but first of all, I would like to start with Mr. Raj Ganguly. Mr. Suman S. Mr. Ravi Teneti. Mr. Karavadi Sri Vaskumar. Mr. Murli Manohar. Thank you so very much for being a part of this panel and coming all the way from the US. Miss Neha Avasti. Dr. Neha Avasti, I'm so sorry. My bad. Thank you so very much. Then we have Dr. Yoshila Pakela. And finally, Mr. Mark Kahan, Managing Director, Omnivore, and I'm really, really thankful to him for being agreeing to being a part of this panel and being a moderator and being getting the best out of everybody. Thank you so much, Mark. Thank you all. Not left any. Oh, yeah. Thank you so much.